Today we're going to look at solving this polynomial inequality. So typically we might see like an actual polynomial, then we might have to like factor or do something. But here we just have x minus 7 times x minus 4 times x minus 2 is greater than 0. So what we're looking for is which x values, if any, or multiple or a single value, will make this a true statement. So first thing you want to do is you want to set each value equal to 0. Now you could do this mentally, but we just want to know what's going to zero these out. So this is going to be x equal to 7, because if you add 7, x equals 7, x equal to 4, because if you add 4, and then x equal to 2, because you would add 2. So now from here, I would generate a number line and place these values onto the number line. So we have the x value of 2, we have the x value of 4, and we have the x value of 7. When we put these x values on a number line, we are now creating intervals. So we want to know what happens is, like, what in this region from negative infinity up to 2, we want to take a test point from that region and plug it into the inequality and determine, is that a true or false statement? And if it's true, then x values from that region will qualify as a potential solution. So I want to take an x value in this region and see what happens. And the easiest one, I hope you're noticing, is 0. Test point of 0, because 0 is in that interval from negative infinity up to 2. So I want to take 0, and I want to plug it into every x value in this inequality that we have. So 0 minus 7 times 0 minus 4. 0 minus 2 is greater than 0. What we're concerned about is just to see, really, if it's positive or negative, because we just want to know, is this greater than or less than 0? So I have negative 7 times negative 4 times negative 2. And the more you do this, the more you kind of look for the patterns and just know, like, all right, so I'm just looking for a positive or if it's negative. So I really don't care what the actual numbers equal. Like, I don't care what 7 times 4 times 2 is in this case, because I just want to know, is it a positive or a negative? So we have a negative and a negative, that's going to be a positive. And then we have a positive times a negative, that's going to be a negative. So is a negative value greater than 0? No, it is not. So this region will not be part of my potential solutions. Next, I want to do a number in the interval from 3 to 4. Well, 2 to 4, meaning I was going to pick 3. So in the interval from 2 to 4, here to here, I want to pick a number that's in there. So I guess 3 would probably be our most straightforward. And I'm going to move. I don't know if I can do this. Let's see. Ooh, I can. Okay, I'm just going to move that over. So now we want to take a value from the interval from 2 to 4, and I'm going to take 3. So I'm going to do 3 minus 7 times 3 minus 4 times 3 minus 2 greater than 0. And we're not worried about what the actual values are. We are worried if it's positive or negative, because that's what we want to know. We want to know if it's greater than or less than 0. So 3 minus 7 is negative 4. 3 minus 4 is negative 1. 3 minus 2 is positive 1, greater than 0. Negative and a negative make a positive. Positive times a positive is going to be a positive. A positive is greater than 0. Since a positive is greater than 0, then we would say yes, this is going to be a solution. So we have values in this region here that are going to make this a true statement. So that's going to be part of our solution region. Next interval is from 4 to 7. I don't think I could move it over. I'm going to grab 5. I'm going to go over here. So we're going to do 5 minus 7 times 5 minus 4 times 5 minus 2 greater than 0. 5 minus 7 is going to be a negative 2. 5 minus 4 is positive 1. 5 minus 2 is positive 3. Negative, positive, positive. Negative times positive is negative. So negative greater than 0, no, not a true statement. So in the interval from 4 to 7, we do not have any values, so we're not going to highlight that region. And then finally, last region, 7 out to infinity. Let's just grab 8. So we're going to do 8 minus 7 times 8 minus 4 times 8 minus 2 greater than 0. 8 minus 7, positive. 8 minus 4, positive. 8 minus 2, positive. All positives, greater than 0. So that's a yes in that region. So we're going to highlight from 7 out to infinity out there. Now we want to actually write down our interval because we have a lot of interval. We have a lot of values. Any number between 2 and 4, any number between 7 and infinity. So we have to write out this as an answer. So here's our answer. We're going to write parentheses 2 to 4, parentheses, and the reason I'm not including 2 or 4 is because look, if I took 4 minus 4 is 0. 0 times anything is going to get me back 0. So this is going to equal 0, this whole entire statement, if I say x is equal to 4. 0 greater than 0? No, 0 is not greater than 0. 0 is equal to 0. So that's why I can't actually take those endpoints. So between any number between 2 and 4. So 2.00001, 2.1, 2.2, 3.9999999, but not actually 4. And then I want to union that because I'm skipping over the interval of 4 to 7 and I'm going to 7 to infinity. And same thing with 7. 7 minus 7 is 0. 0 is not greater than 0. So 7 out to infinity, and we always use parentheses with infinity because we can't cap infinity. So then there is our interval for this problem. 2 to 4 unioned with 7 to infinity. Good, interesting problem today.